You can ask him to leave to share.
Okay, can you let me share?
Yes, just 1 second. Yes, now. Okay, we can see your screen. Bismillah ar-Rahman ar-Rahim. Assalamu alaikum wa rahmatullah. Dear participants, I would like to introduce to you Professor Omar Hassan Kasuli, and he will tell you about himself. He's a professor of epidemiology and biostatistics. He had his Doctor of Philosophy from Harvard University and his Master of Public Health also from Masters University. He will introduce himself, then he will start his presentation. Please, Prof. Omar.
Bismillahir Rahmanir Rahim. Wassalatu wassalam ala Rasulillah. It's a pleasure to be with you this morning. I am the chairman of the Institutional Review Boards at Princess Noura University and King Abdullah bin Abdul Aziz University Hospital. Also, I was chairman at King Fahd Medical City, so I am involved a lot with research. Our discussion today is going to be about study designs. Study design means the strategy you will use to capture the data that you will use to study the relationship between the independent, which is the causate, determinant, and the outcome variable. It's the strategy. There are two main strategies that we use. We can use the non-experimental, which is also called observational. This is to just look, we don't intervene. Or we could use the experimental, which involves intervention. Most of our research and epidemiological work is based on the observational and not the experimental. So we shall spend more time on the observational. Now, I will be stopping from time to time to answer your queries. Please write your queries in the chat. Let us start with observational studies. These have no intervention. You just watch passively. You allow nature to take its course and you just watch and get the information you need. These studies can be descriptive. You just describe the picture of the disease. Who has the disease? Where do you find the disease? Or they can be analytical. Observational studies also can be used to study the relationship between the risk of a disease and the disease itself. Experimental studies, on the other hand, are interventional. You take deliberate action to change something on the human being and then see what the outcome is, like you give them a medicine or a drug. The experimental studies are more difficult logistically. They cost more money and they have got ethical issues if you do them. Laboratory experiments also experimental. They have few ethical issues, but are expensive. So now we have seen two main strategies of study design: observational and experimental. Now let us look at the strengths of observational studies. These studies cost little money because you just watch, you don't do anything. They are convenient and they have no ethical controversies because you don't do anything with the human body. As I said, they are cheap and you can study a lot of human experiences. They also have got few ethical problems, and this is why they are very popular. They, however, have got some weaknesses that they are liable to confounding effects. Because you don't have control, you are just observing, there may be confounding. Confounding means extraneous, extra factors that can affect your results. And these usually are unplanned. You have no control over them. They can affect your results. The other weakness of these studies is that they cannot be used to study etiology directly. It is studied only indirectly by comparing disease in lessen smokers and non-smokers. Also, you cannot get the variable of interest. You, for example, may be interested in the incidence of COVID, how much COVID occurs, but you are not there when somebody gets COVID. The information you get is how many are admitted to the hospital. So we usually use surrogate variables in observational studies. In experimental studies, no, because everything is under your control. You use the variable that you are actually interested in. Now that's about observational studies. We have seen their strengths and their weaknesses. Now let us look at experimental studies. They have got a strength that you can control extraneous variables. You can randomize. This is a technique of dividing into two groups and comparing two groups. It gives us stronger results. In experimental studies, you can control the extraneous variables. You can vary them and change them. So you actually are in control. So you can make a better and more effective study. The experimental studies, however, have got some weaknesses and disadvantages. The biggest one is you cannot do experiments on humans. If you tell a human, don't eat for 3 days, they will eat. If you tell them, take this drug every 3 hours, because you are not there, they may take it. So it's difficult to do these experiments on humans because humans will not obey you. And you cannot observe them for 24 hours. Of course, there are ethical controversies in experimental studies. Like if you are giving a drug, it may be dangerous, it may cause risks. So that's an ethical problem. So these studies have got a lot of ethical problems. Now we end the first section. We've talked in this section about observational and experimental studies. As I said, if you have a question, a query, write in the chat. I will see it and answer you. Okay, so far we don't have anything in the chat. Now I will go on to talk about the first type of observational study. There are 3 types of observational studies: the cross-sectional, the case control, and the follow-up. Now I will talk about the first type, which is called cross-sectional study. Of course, I will define it and I will see how it is designed and analyzed, and I will talk about its strengths and weaknesses. There are some keywords you need to remember. The word cross-section is important. Prevalence study, ecological study, these are all names for cross-sectional studies. These studies study the prevalence of disease. They study the disease at the moment, how much of it is there. At the same time, they study the prevalence of the risk factor, the putative cause of the disease, so that we can determine the relationship between the two of them. Now, the cross-sectional study, as I said, determines the risk factor, which is the cause, and the disease at a point in time. This is very important. It's at a point in time. A cross-sectional study is done at a point in time. This minute, you look in your classroom, you want to see if there is a relationship between gender and wearing glasses. You look at the class at this point in time, and then you see how many males have glasses, how many females have glasses, how many males don't have glasses, how many females don't have glasses. This is a cross-sectional study. You get this information, do some statistical analysis, and you get your answer. So simultaneously, we ascertain the outcome and the cause at the same time. And this is a hallmark of a cross-sectional study. Now, a cross-sectional study can be descriptive, just to describe disease, or analytic, to tell us the cause of the disease. And you may repeat it several times. You may do it based on individuals or based on groups. If based on groups, it's called an ecological study. The cross-sectional studies are used in community diagnosis, finding out what is the disease pattern in the community. When you want to start disease etiology, you always start with the cross-sectional study before you carry on more difficult ones. It's also used in public health and program evaluation. So administratively, the cross-sectional study is used a lot. But as I will explain later, it's not so good in determining etiology or cause of disease. It has got the big advantage that it is easy, simple. You can carry it out and get rapid answers. The example I gave you, if I wanted to know whether there is a relationship between wearing glasses and gender, I can do it in a classroom in just 10 minutes and I get my results. So this is the hallmark of cross-sectional studies. They are simple and they are rapid. And in reality, when you start doing your research, you are going to use the cross-sectional design a lot because it's the easiest one and the quickest one. Most of your research is likely to be cross-sectional. What are the disadvantages of this type of study? So you cannot study etiology in a definitive way because of the time sequence. Like the example I gave you, glasses and gender, well, that one we don't know. You don't know what came first. You may not be sure what comes first. Smoking and lung cancer. Sometimes people have lung cancer and they smoke because they feel a scratch in their lungs and they need something warm there. Or maybe the smoking came before the lung cancer. So the time sequence is always difficult to determine. And they are not good at studying uncommon diseases. And you cannot study these extraneous variables we call confounding factors. So, and most of the diseases that we study are those of long duration. Diseases of short duration, they are not there by the time you come to study. So these are disadvantages of the cross-sectional study. It's several disadvantages, but remember, it has got the big advantage that it's quick and it's very easy and very convenient. When you do a cross-sectional study, you summarize all your data in what we call a 2x2 table. As you can see, on this side is the risk factor, let's say smoking, say yes or no. Up here is the disease, lung cancer, yes or no. Inside the cells, you put numbers. A, for example, smoke and got lung cancer. B, smoke, they did not get lung cancer. C, they didn't smoke, but they got lung cancer. D, they didn't smoke and didn't get lung cancer. So these are the only 4 possibilities. You make this table, and later on in the course, they will teach you how to do statistical analysis. I am not going to go into that, but this is the final result of a cross-sectional study. And there are statistical parameters that are involved. We will not go over them now. They will be covered later when you do the statistics. So now we come at the end of the first observational study, which is the cross-sectional study. Before we go on to the next one, I want to see if there is a question in the chat. So far, no question. Okay. Now I will move on to talk about the second type of observational study. This is called the case control design or study. Notice that there is a gradation. The simplest is cross-sectional. We have just covered that. Then the next more difficult is the case control study. It's more difficult, but it is more accurate. So we are going up in terms of accuracy. We are going to define a case control study. We'll talk about its design, how it is designed, the strengths and weaknesses. And then we'll talk about how to choose cases and controls. By the way, the case control study has become very popular in epidemiology these days. Most people use case control studies. So there are some words you need to remember. Case selection. Case is another word for disease, using people with a disease to study. Case control is the name of the study. Some are case only, it's very complicated. And there is the odds ratio. This is a statistical way of measuring the relationship between the disease and the putative cause. And population base is the group of people in which we do this study. Okay, so the case control study, as I said, is very popular because it has got low cost, it is rapid, and it's flexible. It has got these advantages also found in the cross-sectional study, but the case control is better than the cross-sectional because you use a small number of subjects. You can do a decent study with 50 only, with the 30 cases of a disease. And it has got the ability to study both rare and non-rare diseases. Now, let us get the terminology right. Cases means people with a disease. Controls means people without the disease. It's called case control because you are going to compare people with the disease to people without the disease to see how they differ in terms of the putative or alleged or suspected cause of that disease. Now, how do we select the cases? We said the cases means the people with the disease. We'll see in the chat if we have a query. So far, no query. So we'll continue. So when you are going to choose, do a case control study, make sure that you have got a population. You may have a village, you may have a hospital, you may have a school, but make sure that your cases, the people with the disease, and controls, the people without the disease you will use to compare, come from the same population. Now, how do we identify cases? Very easy. We can go to clinical records. If it's a hospital, we go to the records. We can go to the discharge records, disease registry, employment records, death certificates, anything that can tell us about disease, we can use it to identify our cases. So the cases must be people who have the disease that we are studying, but we choose only new cases. We choose only those who have been diagnosed recently. We do not pick people who have been sick for a long time. Only incident cases, which means new cases. Now, how do we get information from the cases about the cause? Because we are looking for cause. We can interview them, ask them, do you smoke? We can check their hospital records if they got a certain medicine. We can check the environment, is it dirty? We can check their genes. We can check biomarkers. Biomarkers are chemicals in the blood. Or we can make physical measurements. We take their weight, their height, or laboratory measurements, hemoglobin and other things. So we get information from the cases. And then now, what are the strengths of the case control study? So you get the information I said from cases and controls, the same information. Then you will discover the cause, because you will discover that cases have got more smoking than controls. Then you know that smoking is the cause of this disease. Okay, now there is a question here. Can we use the case control methodology in two diseased groups? Normally, we do not, but we could also use it, in which case the controls are people with a disease different from the one we're interested in, and we use them as a control. But that's a rare situation. We normally do not do it that way. Okay, what are the strengths of the case control design? As an epidemiologist and a statistician, I love this word, OR, odds ratio. It's a powerful indication of the strength of the causality. And you calculate it from the case control design very easily. So this is a big advantage, the odds ratio. Now, case control also have a low cost, because as I told you, you use few patients and few controls, and so short duration, doesn't take long. You choose the case and controls, then ask them about their smoking, about their eating, and then you have your results. And it's very convenient, because in a case control study, you meet the person once, you don't see them again. You meet them for 10, 20 minutes, get your information, and that's it, you don't see them again. However, it has got some weaknesses. Some of these are very statistical in nature. We cannot measure the risk ratio. You will be taught what the risk ratio is later on. They give you the probability of exposure if you have disease, instead of probability of disease if you have got exposure. Again, this is a statistical matter. You will be taught later on, but I can prove to you statistically that the two are the same. One of its weaknesses is that we don't know the time sequence. If we find somebody with lung cancer and he chews tobacco, we don't know whether the tobacco came first or the cancer came first. And there is a bias. There are several biases that are likely in a case control study, like misclassification. You misclassify people. Somebody tells you, I am a smoker. But if you ask in detail, what they mean is there was a party one time and they puffed at a cigarette. So you classify this one as a smoker when really they are not smokers. And so historical information is difficult to validate, because people tell you what they did, but you cannot prove it. You have to listen to them. And confounding factors may be difficult to control for in a case control study. So this is the second design, and this is the result. Again, the results of a case control study is a 2x2 table. You have cases above and controls, and then exposure, this is the cause. You have A, B, C, and D. It's the same as the cross-sectional study, but the margins are a little bit changed. And from the information we get from this table, we can calculate the odds ratio. The odds ratio tells you how much more disease is in the people who smoke than, say, those who do not smoke. Like for lung cancer, people who smoke a lot have got an odds ratio of up to 16 times more likely to get lung cancer if you're a smoker than if you are not a smoker. So now we have finished the second type of observational study. If you want to recapitulate, we started with the cross-sectional, which is you come to a place, a population, take a still picture, like use a still camera, and immediately count people who have got the disease, those who have got the putative cause of the disease, and you make a 2x2 table. Then we talked about the case control, in which you find the people with the disease and then look for people without the disease, called controls, and compare them in terms of their exposure. Exposure could be eating meat or smoking or using a certain drug. When there is a difference in exposure between the two, then that exposure is the cause of the disease. We've proved it. So that's how the case control study works. Now I want to move on to talk about the third type of observational study.
Excuse me, Professor.
Yes.
There's a question in the chat. One of the participants is asking, can we also use it in two diseased groups? Like one group will use a new drug and the other group will use the old drug.
Yeah. Yes, usually the case control design is used for just people with a disease and people without the disease. Usually it's about disease. It's not about the drug. Usually it's about the disease. So we use it in one disease group, not two disease groups. This is how it works. Yeah. Okay. Now, can we move on to talk about the third type of observational study? This is the follow-up, or cohort design. As I told you, we are moving in steps. Cross-sectional is the easiest, but it is the least accurate. Case control is more involved, a little bit more difficult, but more accurate than the cross-sectional. Now, the follow-up is a lot more difficult to carry out, but it is the most accurate of observational studies. I will show you a chart later on so that you can see all the 5 study designs. There are 3 observational study designs: cross-sectional, case control, and follow-up. And there are 2 experimental study designs: community randomized and clinical randomized study. We will not go into details about the experimental studies in this presentation. They will be covered in a later course, but I will tell you the major elements of them. So in total, we have got 5 study designs, 3 observational and 2 experimental. Now let us talk about the 3rd observational type of design, which is the follow-up or cohort. We'll define the cohort and talk about the types of cohort studies, and we'll talk about how it is designed and analyzed, and we will talk about the strengths and weaknesses. Please notice that for each study design, I tell you what are its strengths and what are its weaknesses, because you have to make a choice of what study design to use for your research. So you need to know the weaknesses and strengths so that you can make the right choice. Okay, now the keywords here, we use the word cohort or follow-up. They mean the same. Cohort and follow-up mean the same. The cohort means a group. It could be a closed group or open group. It means a group that we follow up. In a follow-up study, we get a group of people and follow them up for a time. Now, the follow-up study or cohort study can be ambidextrous. You can follow up both forwards and backwards. Forwards, you watch people for 1 or 2, 3 years, see what happened to them. But backwards means you look in the records, what happened to them before you met them. So ambidextrous is both forward and backwards. Retrospective is the word we use to mean backwards. Prospective is the word we use to mean following up forwards. And there is this term loss to follow up. As long as you're going to follow them up for some time, you may lose them. You know that you don't end up with the same number that you started with. Okay, definition. What's a follow-up study? A follow-up study is also called a cohort study, and has got other names. We don't have to go over them. It's got several names, but the commonest a follow-up study or cohort study. What does it do? It compares disease in exposed. Here you have got 2 groups. One group is exposed, okay, and the other group is not exposed. Exposed means exposed to the possible cause of the disease. Like let's say cigarette smoking. We've got 2 groups. One group smokes, the other group doesn't smoke. So we follow those groups for 1, 2, 3, 4 years. And whenever disease appears, okay, we count it. Another disease appears, we count it. So after time, we count how many cases of disease occurred among the smokers and how many cases occurred among the non-smokers. We do some statistical computation and we decide whether smoking is the cause of this disease. Now let me repeat this. It can be prospective, means forwards. You get people and start following them from now onwards to see what happens. But it can be backwards because we have got records. We can know from records whether people were smoking 2, 3, 4 years ago and whether they got cancer 2 or 3 years ago. So it can be forward, can be backward, or can be ambidextrous. Ambidextrous means both forward and backward. You can, in one research project, do both forward follow-up and backward follow-up. So, yeah. Am I clear? Let me see in the chat if there is a question there. No, there's no question. Okay. Now, as I said, a follow-up study, you get a group of people and you follow them up. This group may be closed, fixed. You come to Al-Ma'rifah and get the beginning class of pharmacy and say, you are my cohort. I'm going to follow you up for 3 years and see what diseases you get. Whenever there is a disease, please tell me. that cohort is fixed. But sometimes we can use a dynamic cohort. It's a cohort that changes. For example, you can go to the mall and you say, well, my cohort are people inside the mall. You stay there for 1, 2, 3 years and count many diseases that occur. But it's not the same people every day, because every day some people go in and others go out. People go in and people go out. So that cohort is dynamic. So we can use a fixed cohort or we can use a dynamic cohort. The dynamic cohort is a little bit more complex to understand, but it's very useful. The difference between them is that the statistical analysis is different. A fixed cohort, we use the cumulative incidence, but a dynamic cohort, we use the incidence rate. All of these things will be taught to you in due course as we go further in our study of research methods. Now, what is the design of this? We get a study population. As I said, our study population is going to be the entering class in pharmacy. We divide the class into 2 groups, exposed and unexposed. So we ask them who is a smoker and who is not a smoker. So we have got 2 groups. We are going to follow this class for 5 years or for 4 years and compare disease occurrence in the smokers who are exposed and non-smokers who are unexposed. This is how the cohort study works. Sometimes the group is very big. We may choose a cohort from a whole village of 10,000 people. So instead of following up everybody, we take a sample. We take a sample from smokers, take a sample of 100 from smokers, and take another sample from the non-smokers who are unexposed. So we may follow up the whole population if it is small, like the entering class in the Faculty of Pharmacy, or we can take a sample and follow up the sample. So what we do, we follow up the 2 groups, the exposed and unexposed. We watch them for a period of time to see how disease occurs. In the end, we want to compare occurrence of disease in the 2 groups, in which group has got more disease than the other. Now, where do we get the cohorts? Where do we get the groups that we are going to compare? Before I continue, let me see in the chat. There's a no question yet. Okay, it seems you're following. Usually, we select groups that are convenient, like factory workers. If you go to a factory and follow people in the factory, because they come to work every day. Or you can follow people in a health insurance. There are several insurance companies we've got here. You've got Takaful Rajihi, for example. You can say, okay, I am going to use the people in Takaful Rajihi as my cohort, because you know who they are. And when they get sick, they go to the hospital. So you will know that they have got disease. Or you can follow people in an institution like the army. People in the army are always there. People in the police are always there. People in the university also are a good cohort to follow. But problem is, people in the university usually, some people drop out, some people join, they change universities, so they are not so stable. But army and police are very stable. So you are sure you will always find them when you come back. So that's how we get the cohorts to study. How do we get information about the exposure? How do we know the exposure? We can use existing records. We can interview them. We can examine them. We can take blood, or we can examine the environment. These are the exposures. and outcome. Now, this is the disease. Follow-up studies take a long time, 1 or 2 or 3 years. If you do them for a very short time, you don't get good results. So you have to be patient with them. So outcome assessment comes after a long time. So we need to record when the disease occurs, we must record the time when it occurred. In some people, it occurs after 1 year, in others after 2 years. We must also use standardized criteria. If the disease we are looking for is lung cancer, we must have standardized clear criteria that we shall use. Histology, for example. So anyone with a disease, the way of ascertainment, of diagnosis must be the same. How do we follow up? We can always write them a letter. Every 6 months, we write them a letter. Have you got a disease? And they answer. Or we can call them on the phone. Sometimes, maybe we lose them, we cannot find them, so we look at death certificates. As you know, whenever people die, a death certificate is issued. If you go to the Diwan al-Ahwal al-Madaniyya, you can always find out who has died, but of course you need permission to be able to do that. Death certificates, the hospital records, you can find out who in your cohort died, got the disease that you are looking for. Now, one of the most important things to be equal, to make sure that the two groups that you're following up, you follow them up in the same way. Because if one group, you look more strictly for the disease, another group less strictly, you may end up with a bias. So you must use the same ascertainment and surveillances. Now, what are the problems of follow-up studies? Because they take a long time, non-response. Somebody can enter the study willingly, but after 1 or 2 years, they no longer respond to you when you ask them what is happening to them. They get tired or lost to follow up. They may migrate and go to another area. You may lose their telephone number. You may lose their address. So loss to follow up is a big issue. Bias. Follow-up studies have got a lot of bias. First of all, there's selection bias. When you are selecting people into the two groups, you may be biased. You may put in the group of smokers people who shouldn't be there. And this happens. You come to an old man, very well dressed, very respectable, he's a sheikh, and you ask him, do you smoke? He says, I smoke. No. Do you really smoke? Yes, I do the smoke. No, please make sure. You know, then he says, okay, I don't smoke. So you put him in the non-smoking group. The problem is you, because you are biased. The way you look at him, you don't expect him to smoke. So in a way, you force him to agree he's a non-smoker and put him in that non-smoking group. Follow-up bias, this is when you look for the disease more in one group than the other. Let us say you look in the smokers more often than the non-smokers because you expect disease in the smokers. That's a bias. Information. You may be biased in the information you get because you expect disease in the smokers. Maybe you look for more details. And then there is what we call confounding bias. This is when extraneous, unexpected factors get involved. The concept of confounding is complex in epidemiology. You will be studying it in due course. Confounding means confusing. It comes from the French word confondre. There's factors that can confuse you. And a good researcher has to be aware of the confounding factors because they will bias your study. Now, the follow-up study we can calculate a lot of statistics. It gives us more statistics than the cross-sectional and the case control study. We can calculate incidence of disease. We can calculate risk of disease. There are statistics for each of these, and you will be taught the details. For incidence of disease, we use incidence rate and cumulative incidence. And the risk statistics. Risk means how much more disease is in the smokers than the non-smokers. So the statistics that we use are the risk ratio, rate ratio, relative risk, and the odds ratio. You will be taught what these are and how to calculate them in due course. We cannot go over them right now. Now, follow-up studies have got many advantages, but I just want to underline one, the time sequence. In a follow-up study, you are very sure that the disease occurred after the exposure, because you took in somebody who was smoking but has no disease. After 2 years, he gets the disease. You are sure that this disease is from the smoking. So that's a big advantage of this type of study. Now, it has got disadvantages, and the biggest one is loss of people. As you go on, you lose people, and your sample becomes smaller. Also, you have to use very large samples. Follow-up studies use thousands of subjects to be able to get good results. And because of that, they cost a lot of money. Now, at the end of a follow-up study, again, you get a 2x2 table. This 2x2 table is something that you cannot escape in epidemiology. It occurs everywhere in all studies, and all analysis starts with this 2x2 table. So now I have finished the third type of study. We'll check the chart. Okay, no question. Now I will go on to talk about how do we decide what study design to choose. The first thing is you need to identify the population. You need to decide where will you do the study. The people who you will study. Could be a geographical area, it could be an institution, but you need to choose your population. Then after that, you have to make sure that the population you choose is representative, is accessible, and you know the total number, and you can get the numbers of people you are after. After choosing the population, we choose a sample, because most of the time we cannot study the whole population, we study a sample of the population. Now, sampling is a technique that you will be taught later on, how to choose a sample from the population, because the sample represents the population. You cannot study the whole population, and there are many ways of selecting. You may select it in a scientific way when it's random, or it may be non-scientific, non-probability. It could be a convenience sample, quarter sample, purposive sample. These details will be taught to you later on. Now, let us look at the studies that the 5 main study designs. As I told you, observational studies, you do not interfere. You just collect data. We talked about the cross-sectional, we talked about the case control, and we talked about the follow-up. Experimental studies, here you intervene. You do something. The randomized clinical trial is done in hospitals when they have got a new drug to test. They come and take patients, divide them into two groups randomly. Randomly means you close your eyes and divide them into 2 groups. Because if you don't close your eyes, you may be biased. One group you give the drug, the other group you do not give the drug. And then you watch the 2 groups to see who gets better, where there is better cure. That is called a randomized clinical trial. It's an experimental study because you intervene. The same experiment can be done at the level of the community. You may have a new vaccine. You want to test whether this vaccine is effective or not. So one village, you give them a vaccine. The other village, you don't give them a vaccine. That's what they're doing with the COVID vaccines. Some people are vaccinated, others are not vaccinated. And then they see how many people get COVID disease in each of these groups. So these are the 5 study design types. Now, which one do we choose? It depends on what you are doing. The cross-sectional study is used in a preliminary way. When you are just beginning to understand a disease, you use a cross-sectional study. After that, you use the case control, because case control is very good to determine etiology, to determine cause of the disease. But to confirm etiology, you use the follow-up. It's very accurate in terms of follow-up. And I told you the time sequence. You know that the disease occurred after the exposure. The experimental design is the final proof. It's the most accurate in terms of causality or efficacy, but we said that experimental studies involve intervention on humans. They carry high risk and they have got many ethical problems. So we'll end here and I will see if we have got a question in the chat. We'll answer it quickly before moving on to the next lecture. Thank you very much for listening. Okay, we don't have now.
Professor Omar, that was very interesting. Even to me, I heard this talk many times, but this was very well organized. Thank you very much. And then if anybody has got a question, and everybody is thanking you. Thank you. Yes, anybody? Okay,
Yeah.
everybody.
Okay, inshallah. Inshallah. We'll now close.
12 o'clock, inshallah.
Inshallah. We'll meet again, inshallah, another time. Salaam alaikum.
Alaikum salam.